In this video, we are going to continue to explore unit rate problems that involve fractions. And there are some pretty challenging problems to set up. And we're going to go over some strategies to solve these types of problems. And we'll go over a couple different methods. An example of this type of problem is Emily needs to read 85 pages from her history book. If she can read 1 1/6 pages per minute, how long will it take her to finish her assignment? The setup of this problem is not so challenging in that we're given a unit rate of 1 1/6 pages, 1 1/16 pages per minute. So I'm going to set that up in my table of pages per minute, and it's telling us 1 1/16 pages per 1 minute. The question is asking us, how long is it going to take her to read these 85 pages? And herein lies the real difficulty of this problem. How are we going to go from 1 1/16 to 85? One strategy that you might have thought is, especially because we're not as comfortable working with these fractional relationships going into numbers and using division, is to convert this fraction into a decimal. So what is this 1/16 as a decimal? So we can call this, instead of 1 1/16, we can call it 1 point something. When you turn a fraction into a decimal, it doesn't always work out precisely because of rounding error. So in this case, you can't just stop at the hundredths place. We really need to find out what is this fraction as a decimal and be precise about it. So to do that, we're trying to find out what is 1/16 as a decimal. So as a decimal, we need to get rid of that denominator. We need to get that denominator to 1. So we're going to divide each side by 16. So essentially 1 divided by 16. 16 goes into 1, 0 times. We're going to add a decimal. 16 goes into 10, 0 times. Add another 16 goes into 100, 6 times. And I believe 16 times 6 is 36. So that's 96. So we would have 4 remaining. 16 goes into 40 2 times. That's 32. We would have 8 remaining. And 16 does go into 80 perfectly. 16 times 5 is 80. So you need to be precise with the decimal. You might have thought, I'm going to stop here. If you stopped there, then we would be calling it just 1.06 as when we turn it into a decimal. That's going to result in rounding error, and that will not go into 85 perfectly. So if you're using this decimal strategy, you need to see it through. So as a decimal number, we would call 1 1/16 1.0625, and that is equal to 1 1/16. Now you have something that you can use, and you can think, to go from 1.0625 to 85, what do I need to multiply by? And you'll do the same thing on the other side. I'm going to go ahead and erase my work. Here's the other difficulty in doing this. This is a very difficult division problem. To figure out what you're multiplying 1.0625 by to get to 85, you need to think, I have to do 85 divided by 1.0625. And we're multiplying, we want to get rid of this decimal, times 10, 100, 1,000, 10,000, or multiplying by 4. So now our problem looks like 850,000 divided by 10,625. Even though it looks big, we're still, 10,625 won't go into 8, 85, 850, 8,500. So we're going to go all the way to 850,000. And I know that it goes in 8 times. And this is going to take a long time to figure out the multiplication. But 10,625 times 8 is actually exactly 85,000. Sorry about that comma there. And there's no remaining. Bring it down to 0, and it goes in 0 times. So it does work out perfectly to 80. But you can see if we did a rounding error, it wouldn't have been so precise. And that's where the difficulty in these types of problems lie. All right. So that gets pretty challenging. So let me show you another strategy you can use. Think about getting rid of this denominator, but keeping it in a fractional form. And there's actually quite a few different ways that we could use it. I'm going to show you 2 different strategies here. And I know these are difficult. There's a lot coming at you. But you can see if one of them sticks better than the rest. Let's just extend this rate out. And we can make a table. If it's 1 1/6 pages in 1 minute, in 2 minutes, there would be 2, I have to switch the colors, 2 2/16. Because every minute I'm adding another 1 1/16. In 3 minutes, there would be 3 3/16. See if you start to notice a pattern. 4 minutes would be 4 4/16. Our goal when working with fractions is to be able to, if you think about what a fraction means, it means 4 parts out of 16. It's less than a whole. A whole would be 16/16. That's 1 whole. So if we continue with this pattern, we want to be able to get it to 16 16/16. So, and it would continue at this rate. So in 16 minutes, or we can think about multiplying by 16, we would be at 16 16/16. Well, that 16/16 is a whole. So what this really means is 17 pages in 16 minutes. And that's the unit rate. It's 17 pages in 16 minutes, or 16 16/16. But right here, 16/16 is a whole page. That's the entire page. And so then if you saw this relationship at the beginning, you could think, okay, I want to get rid of this denominator. The only way to do it is to multiply by 16. Multiplying with 16 will give me 16/16, or 16 16/16, which is 17. And then from this is now my new unit rate, we can easily get up to 85 by doing 85 divided by 17, which is just 5. 17 times 5 is 85. So then we multiply by 5, and we would get 80 minutes. I recognize that seems tricky. Let me show you one other strategy. To know 1 1/16 pages per 1 minute. 1 1/16 is, what we're saying is it's 1 whole, and remember that 1 whole is 16/16 is a fraction. That makes a whole. 16 parts out of 16. If I made a bar and divided it into 16 parts, the whole thing would be considered 16/16. So knowing that a whole is 16/16, 1 whole would really be 17/16. So what we're saying is, in 1 minute, she reads 17/16 pages. Well, in fractions, and if you have a background with fractions, we can't go from, we need like denominators. So we need to figure out a way that right now 85 has a denominator of 1. So we can't figure out how do you go from 17 sixteenths to 85 firsts. So we would want to convert this into a denominator of 16 by multiplying each side by 16. And 85 times 16 is 1,360 sixteenths. So then what we're saying is, how do we go from 17 sixteenths to 1,360 sixteenths? Now, each of these pages has that same proportion. We're talking about 17 sixteenths, so each piece is the same size, going from 1,360 sixteenths. Now we don't need to worry about the denominator, and you can think 1,360 divided by 17 to figure out what to multiply by, and you're multiplying by 80. Very difficult concept. So we're going to start playing around with this and use whichever approach to it that resonated with you the most. I'm going to do just a couple more problems here. It's going to be a longer video. And let's see if you can make sense of them. If this problem says Gordon worked 7 5/8 hours and was paid $13 3/4 per hour, how much did Gordon earn? Well, we have the unit rate, and I'm going to do two different strategies. Our unit rate is dollars per hour, and he's getting $13 3/4 per hour for 1 hour. I'm going to convert this into a decimal form, and in this case I will do instead of 13 3/4, I'll call it 13.75 because I already know that, and I want to get to 7 5/8 hours, and I'm going to work in decimals, and I'm going to do 5/8, and in this one I'm just going to show you with my calculator. 5/8 as a decimal is 0.625. So that equals 7.625. So in this case, I'm just going to multiply each side by 7.625. Same thing here. And once again, for the purpose of time, I'm just going to use a calculator. 13.75 times 7.625, and 13.75 times 7.625, that's 104.8. Let me just make sure I did that right. Yeah, $104.84, I suppose. And that happens with decimals sometimes. We get a little bit of rounding error. If I was to stay in fractional form, dollars per hour, and I was calling this 13 3/4 per 1 hour, to get to 7 5/8, I'm just multiplying by 7 5/8. So I'm going to multiply this by 7 5/8. To do that, I want to work in something called mixed numbers. Remembering that 13, every time we have a whole on this side, is 4/4. So 13 is really, if each one of these is a fourth, and we're saying we have 13 wholes, every whole has 4 parts, so 13 of these would be 52. So it's really 52/4 and 3/4 more. Or you can think 4 times 13 plus 3. And so we really have 55/4, and we're multiplying 55/4 times 7 5/8. In this case, 8/8 make a whole. So we really have 56 plus 5, which is 61/8. So we need to really multiply that times 6